Welcome to Natural Polytechnic. I am Sima Raut, part of General Science Department, subject Engineering Mathematics 1. Today our chapter number is 5 and chapter name is 3-dimensional coordinate geometry with straight lines. Equation of a plane. Plane equation. What do you mean plane equation? Plane in a 3-dimensional. Plane is defined as surface such that the straight line joining any two points on the surface lies wholly on it. Let's see, here P is a point, Q is a point. Any random point on the line, you join it. If the whole total line is lies on the plane, then you can say that this is a plane. This surface is a plane. Every point of the line lies on the surface, then this is called as a plane. Okay, let's see. General equation of a plane. Generally, the equation is ax plus by plus cz plus d equals to 0, where a, b, c are DRS, direction ratios of the normal to the plane. Not all are 0, means a, b, c, in between a, b, c, not all are 0 at a time, and a d equals to constant. A, b, c are all the coefficient a, b, c are direction ratios of the normal to the plane. Then this is called as plane equation. Case, equation of a plane passing through the origin, then d must be 0. If the plane passing through origin, then d equals to 0. Constant must be 0. Then what should be the equation of the plane? Ax plus by plus cz equals to 0. Planes parallel and perpendicular to the coordinate axis. First of all, plane parallel to x-axis. There are three coordinate axes: x-axis, y-axis and z-axis. First of all, if the plane parallel to the x-axis, then that what should be the plane equation? Plane equation is x coordinate must be 0, so by plus cz plus d equals to 0. Okay. Equation of a plane parallel to y-axis, then y coordinate is 0, then ax plus cz plus d equals to 0. Equation of the plane parallel to z-axis, that means z coordinate should be 0. This is ax plus by plus d equals to 0. Let's see. Equation of a plane perpendicular to x-axis, that means x-axis perpendicular means x-axis x equals to k. Equation of plane perpendicular to y-axis is y equals to k. Equation of a plane perpendicular to z-axis, that means z equals to k, where k is any constant, any real number. Okay. Let's see. Equation of a planes parallel to the coordinate planes, that means coordinate planes means there are three planes: xy plane, yz plane, zx plane. We can say that yx plane, zy plane, xz plane, but we can say that there are three planes: xy plane, yz plane and zx plane. Equation of plane parallel to xy plane, that means z equals to a. A means any constant. Equation of a plane parallel to yz plane, that means x equals to b. B is any real number or constant. Equation of a plane parallel to zx plane is z equals to c, means a, b, c here are any constants. Okay. Find the direction cosines of the normal to the plane. Plane equation is x minus y plus 1 equals to 0, and our question is find out the direction cosine. So first of all, we know that direction ratios are on the plane equation. What is that? X coefficient, y coefficient and z coefficient are the ABC or direction ratios. So direction ratios of the normal to the given plane is 1, x coefficient is 1, y coefficient is minus 1, z coefficient is not there, so it must be 0. Then direction cosines must we know that if the direction ratios are given, then direction cosine how to find out? L equals to a by root over of a square plus b square plus c square. M equals to b by root over of a square plus b square plus c square. N equals to c by a square plus b square plus c square root over. Okay. So here a is 1, b is minus 1 and c is 0. So you just put down the formula, we get 1 by root 2, 1 by root 2, 0. So direction cosines of the normal to the plane is 1 by root 2, 1 by root 2, 0. L is 1 by root 2, m is 1 by root 2 and n is 0. So now, equation of a plane passing through a point is x0, y0, z0, and DCS, direction cosine of its normal is Lmn. So let's see here, this is a plane, Q is a point is given x0, y0, z0, and P is any random point on the plane x, y, z, and N is the normal direction cosine is Lmn. Then what should be the plane equation. Lx minus x0 plus m into m y minus y0 plus n into z minus z0 equals to 0. The projection equals to 0. Okay, let's see. Find the equation of the plane which passes through 4 minus 2 1 and is perpendicular to the line whose direction ratios are 7 to minus 3. First of all, we know that if the equation of the plane passing through 4 minus 2 1, then we know that and direction ratios are given 7 to minus 3, then what should be the equation of the plane? Now we know that a x minus 4 plus b y plus 2 plus c z minus 1 equals to 0. You just put down x minus x1 is what? 4. y1 is what? Minus 2. z1 is what? Minus 1. You can write down LMN or you can write down ABC. Since the DRS of the normal to the plane is given 7 to minus 3, you just put down in this equation. What you get now? 7x minus 4 plus y in 2 into y plus 2 and minus 3 into z minus 1 equals to 0. And you just solve it, you just simplify it, you get 7x plus 2y minus 3z minus 21 equals to 0 is the required plane equation. Now we talk about intercept form of plane equation. We know that intercept means what? X-intercept, Y-intercept, Z-intercept. Because this is three-dimensional, so there are three intercepts. This is distance origin to the cutting point of the line on the axis is called as intercept. Distance is called as intercept. Here OA is x-intercept, OB is y-intercept, OC is z-intercept. Okay, so let's see equation of the plane intercept form. We know that in two dimensional x by a is the x-intercept, y by b is the y-intercept plus z by c. C means z-intercept equals to 1. So ABC is the intercept of the axis respectively. Write the equation of the plane in intercept form. Let's see how to find out in intercept form. We just write down the equation in the form of general equation ax plus by plus cz equals to plus d or equals to. So what we get now? 12 is divided by each and every elements of this equation because we have to find 1 in the right hand side. Okay, what we get now? X by 4, y by minus 3, z by 2. So what is we get now? X intercept is 4, y intercept is minus 3, z intercept is 2. Normal form of a plane equation. So let's see, this is the intercept point and normal means perpendicular form. Okay, ON is the perpendicular distance from origin to the end. A is the point and this we get now, this is a perpendicular distance from origin to the end. Then what we get now? Normal form of the equation of the plane must be Lx plus My plus Mz equals to P. P is the perpendicular distance. Okay, Lmn is the direction cosines of the line. Okay. So what we get now? L means plus or minus a by a square plus b square plus c square root over, and we know that this is plus or minus all these things. This is, we can write down Lx plus My plus Mz equals to P, or you can write down in this person. Let's see example. Obtain the normal form of the plane this. So how to find out normal form? So DRS of the normal plane is 2 minus 3 pi. We know that DRS is the coefficients of the plane variables. X coefficient 2, y coefficient minus 3, z coefficient 5. This is the DRS. Then we can find out DCS. We know that the formula. Element we can find out if ABC are given, then element we can find out. In this way, you just find out direction cosines. Length of the perpendicular from origin distance is minus d by a square plus b square plus c square. What do we get now? 1 by root over of 38 because a square 2 square plus minus 3 square plus 5 square. Equation of the normal form. We know that a y in the form of this form we just put down a instead of a, we just put down 2 under root over of a square plus b square is 38 minus 38 or cos 38, whatever you get, only one sign here, plus or minus. Okay, so this is the equation of the normal form. Then equation of a plane passing through three non-collinear points. That means these 3 points does not lies on one line. That means what? Let the plane passes through 3 non-collinear points P, Q, Q R means P x1 y1 z1, Q is x2 y2 z2, and R is x3 y3 z3. Then how to find out equation of the plane? Equation of the plane passing through three non-collinear points, then x minus x1, y minus y1, z minus z1, then x2 minus x1, y2 minus y1 plus z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1, determinant must be 0. This is the format. x1, y1, z1, x2, y2, z2, and x3, y3, z3. These are three non-collinear points on the plane. Then you can find out equation of the plane. This is the formula. Let's see. Find the equation of the plane passing through the points. These are three points, non-collinear points are given. This is x1, y1, z1. This is x2, y2, z2. This is x3, y3, z3. Then how to find out equation? We know that equation formula. How to find out? This is x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1 equals to 0. Determinant equals to 0. That means you just put down x minus x1 is what? Minus 1. We just put down all the values, then we get that the determinant, to find out the determinant, we get the equation of the plane 4x minus 3y plus 12z minus 8 equals to 0. So next video we talk about angle between two planes. Have a good day. Thank you.